All right, let's start. Hi everyone, welcome to the today's session. I hope you all are doing great. Before we start, just quickly type in the chat which domain are you from? Automotive, embedded, firmware, or trying to switch. Just type in the chat. Great. I can see a lot of you are from embedded, automotive, firmware, bare metal. So this session is going to be extremely useful for all of you. So today I'm going to cover a complete embedded Linux roadmap, what companies actually expect in interviews, what you should focus in 2026, and very importantly, stay till the end because at the end I will share exact resources you should follow, what to prepare for product-based companies, and I will also take all of your doubts live at the end of this session. So don't leave in the between. So let's start with this. Why Linux is so important basically. So look at this: 97% of the world's top superconductors basically runs on Linux. Automotive companies are also now shifting from QNX to Linux, and the companies like Qualcomm, Nvidia, TI, and NXP all are heavily dependent on Linux. So if you are targeting product companies, Linux is not optional; it is the baseline skills. Right now, the biggest mistake people make, they don't follow a roadmap, they randomly learn the things. But embedded Linux has a very clear structure. So there I have listed six pillars basically which are important you to master if you basically want to make your career in embedded Linux. Right, so the very first is C programming, Linux system programming, kernel internals, embedded Linux fundamentals, tools and debugging, testing and practice. We are going to talk about each pillar in detail in coming slides basically. Right, so let's start with C programming. So this is non-negotiable. Companies are going to test pointers basically, from pointer arithmetic, dereferencing, double pointer to functions. So a lot of basically memory and pointer related stuff they are going to test you. And then from dynamic memory, definitely you should have clear understanding of memory management, malloc, alloc, realloc, free, and then memory leak detections, how you can use Valgrind for basically detecting the memory leaks. And third, of course, data structure also needed. And I always mention in all of the sessions, like we don't need to go for competitive level C programming, but the basics like linked list, stack, queues, and then basically implementing these direct data structure from the scratch, those are enough for an embedded system engineer to target these product based companies. Right, similarly we have function pointers and callback. This we anyway use a lot even in Linux kernel, so definitely it is great use for any embedded system engineer who is targeting for interview as well as upskilling their career. Right, again, bit manipulation, it's an, you can say that it's also non-negotiable if you're going for any embedded system interview irrespective of your domain. Bit manipulation is the most important programming practice you should do. And then algorithm and complexity, of course, being an embedded system engineer, it is your job to write the optimized code. So you should have the clear fundamentals in your mind as well as clear data structure in your mind, like what the code which you are writing, that is optimized or not. Right, so after C, Linux system programming. So these are basically user space level context which you should be aware about. Like you should be very clear about file operations or the virtual file system which is there in Linux kernel, like how you can call open read write system call from the user space, how you can basically use the mmap from the user space and the kernel, basically how you can use IOCTLs for device communications. Right, and then process and signals, like how process communicate, right, what is zombie process, signal handling. And then of course we have threads. So I have listed out the main topics as well as the subtopics from that particular topic which you should focus if you are planning to shift or upskilling yourself in embedded system, embedded Linux side. Right, and then of course IPC mechanism, like we have different mechanism through which we can, our process can basically communicate with each other. So what are different ways possible, and what is the benefit of each, and what are the cons of each IPC mechanism. And if you are interested in network side, so definitely you should have good understanding of socket, like TCP UDP socket, server client models, and then non-blocking IO patterns. And then device node interaction because like if you are aware about basics of Linux kernel, so in the Linux kernel, basically everything, every device connected to the system is basically treated as a device file, right? So you should be very good understanding like how the device nodes are created, how user space can basically interact with the Linux kernel by using these device nodes, right? And the next pillar is kernel internals and driver, of course, because you are planning for embedded Linux, so definitely you should have good understanding of Linux kernel with respect to like how the kernel modules are created, how you can load the module, how you can unload the module. And one other thing is like only knowing like, okay, so you know, look, you know, like ins mode is for inserting the module, rm mode is for removing the module. That is not enough being an experienced engineer. So if you really want to add the great project in your profile, so definitely you should know in and out of all these commands as well, like how exactly the insertion of module works in Linux kernel, how exactly the removal of module works in the Linux kernel. And then of course character drivers, you should know the clear like what all different component of character drivers are in Linux kernel, how character driver basically register itself with the Linux kernel, how copy to user, copy from user, sorry, user space works in Linux kernel. Interrupt handling, of course, what are the different ways by which you can defer your task in Linux kernel, and what when to use top half, when to use bottom half, and what type of bottom half you should use, whether you should go for soft hierarchy, whether you should go for tasklet, or whether you should go for work queue, for which kind of task you should follow which kind of deferred mechanism, so that you should know very well. And then of course, because concurrency is anyways going to be picture whenever you're working in any real-time project, right? So working and knowing all these synchronization mechanism like spin lock, mutex, semaphore, rcu, atomic operation, so these are definitely going to help you out in clearing fundamentals and upskilling yourself in the field of embedded Linux, right? Then it comes to memory management. Memory management is one of the important subsystem of Linux kernel. You should have very good understanding like how you can allocate memory, how you can deallocate memory in Linux kernel, and which code to use for allocating memory in what scenarios. What are the different flags we generally passed as part of parameters as while we are allocating the memory, and where our memory is going to be allocated, and what will happen if you will try to basically allocate large chunk of memory if it is not actually available in the kernel, right? So these kind of fundamentals you should focus with respect to memory management. Now when it comes to weight queue, you know, like weight queue are used in Linux kernel heavily. Not only in Linux kernel, even if you will talk about RTOS, so there also you will see the weight queues are being used, right? So your process handling basically rely upon all these weight queues. So weight queues are also important to basically understand. Now it comes like most of the people ask these questions like, do I need to know each and everything of Linux kernel? Not exactly. Definitely Linux kernel is very vast, you cannot know each and everything about Linux kernel. It just whenever you get some task, let's say if you need to work on some task which is basically focusing upon task creations and deletion, so as per my suggestion, you clearly go in and out of like how the task is created, how the task control block is created in Linux kernel, how the memory is allocated for that particular task, how the thread infrastructure is basically used for that particular task. So that level of understanding you really need to have. Okay, now we talked about Linux kernel fundamentals. With that, there are other things which you should focus, which is embedded Linux fundamentals. So what comes under embedded Linux fundamental is one thing is like cross compilation, because you are going to compile your kernel on one machine and going to deploy that kernel on the target machine. It could be your emulator, it could be Raspberry Pi, it could be Beagle on Black, or it could be any ARM based chipset or any other chipset basically. So definitely you need a tool chain to cross compile your kernel, right? And then of course, if you have interest in working on the BSP side of Linux kernel, then you should have good understanding of bootloaders, like what are the different stages of bootloader you have, why we use multi-stage bootloader in Linux kernel, right? How the U-boot works, how the environment variables basically get set whenever we are using the U-boot, right? Then we should also clear about the boot sequence, like how the boot gets transition from ROM to SPL and then U-boot and then kernel. So all those fundamentals you should know if you have interest in BSP side of Linux kernel, right? Kernel configuration. This is also one of the most important part, because you are compiling your Linux kernel for different chipset, and for different chipset you need different configuration, right? So kernel configuration provides you the way like how you can configure a different configuration for Linux kernel. You can select which driver you want to compile, which driver you don't want to compile, basically, right? And then device tree also makes an important contribution to the Linux kernel. So definitely, being an embedded Linux engineer, you should be very clear about how the device trees basically benefited in Linux kernel, why board files was not sufficient to use as part of Linux kernel, why device tree was introduced, and how you can compile your device tree, how the string matching happens when your driver is getting matched with the driver, basically, or device, basically, right? And then root file system, of course, for building your kernel and then deploying it onto the device, you need a root file system, right? So how the root file system get built, maybe you can use busybox, right? And how you can compile the busybox, how you can use that busybox as part of your projects, basically, right? And then definitely, because Linux kernel is very vast, you need a build system to build it. So there are various way of basically building Linux kernel. You have Yocto, you have build root. So you can focus, you can choose any of the build system and can start focusing on that to basically learn for the kernel build system. Right now, it comes to the tools and debugging. So there are various tools available in available for Linux kernel. Basically, obviously, you don't need to know each and every tool, but the tool which you might need in your project that you should focus upon. The one important tool is like KGDB. So if you are going to debug issues in Linux kernel, maybe kernel panics, and you want to see the back traces, right, or the remote debugging you want to use, you want to do basically using the GDB servers. So KGDB is the one of the option you can go for, right? So you should understand how you can basically do the core dump analysis and how you can root cause the issues if you face while working on any Linux kernel based project, right? And then S trace is basically because you are going to debug the issues which are encountered while working on device development project. So you should be able to trace the calls, basically, or you can say the process. How you can do that? Definitely, there are a lot of other mechanism also available in NS kernel, but you can go for S trace. So that is the most widely used tool which you can use while you are going to trace all the library calls which are interacting to the Linux kernel, right? And if you have interest on working on the performance side, if you want to basically measure the performance, like how the APIs are behaving, or how the flow from user space to kernel space is happening, what how much time it is taking, how much memory is consumed, basically, definitely when you work on a embedded system project, so the goal is to optimize the memory as well as the power performance, right? So there are various tools available which you can use, right? And similarly, you have ftrace, like it's kind of function graph tracer. You can trace specific kernel functions, like, right? So ftrace is also important, and valgrind, of course, if you want to basically check memory leaks, right? Because memory leaks are not at all accepted in embedded system. That is very dangerous from the safety point of view as well, right? So it's not at all necessary you are going to use only valgrind. If you have any other options, you can use that as well, right? And then static analysis also, like kernel semantic checks and everything it will do, right? So depending upon your interest, you can focus on these tools and basically take help of these tools in debugging your day-to-day issues which you are going to face in your device development, right? Now we know like what we need to focus from a Medal Linux point of view, what we need to focus from driver point of view. We also know like what we need to focus from the C point of view to become a good Medal Linux engineer. Now it comes to like how exactly we can test the driver which we are writing, because that is equally important, right? So how we can do that is, and also how we can practice it. Let's say if I'm not working in any company, or let's say if I will say like I'm not working on any Linux device developer project in my current organization, and I'm not expecting any future project as well, but but I still want to get a good knowledge of that. So what should I do? So first of all, we should start reading basic drivers from the Linux kernel. Basically, I have given you few examples like cat character driver, I2C drivers, right? So with that, you should also have tool understanding of C tags, C scope. So if you're not aware about these tools, you can search on the internet. We cover these tools as part of our Linux kernel and device driver training, basically. And then you should also focus upon few real-time project, basically real driver project, which you can find in the mainline kernel, right? How your GPIO is basically going to interact whenever some interrupt is happening on the GPIO, how the I2C sensor is going to read the data, how the I2C transmission of data basically works with your I2C kernel driver, right? How that platform driver get bind with the with the platform device basically, right? And then definitely you should also practice mock into practice, like you can explain to yourself what exactly kernel scheduler is, how the cfs in kernel works. So write a spin log use case scenario. So here I have listed out few things, but definitely there are a lot more things to be practiced before going for an interview for embedded Linux, right? And then company specific prep as well. Let's say if you're going for Qualcomm, so for Qualcomm, definitely in the mainline kernel you can find Snapdragon related code or the QCOM drivers basically, which you can focus upon and you can get good idea about that. If you're working on TI, so definitely from TI there are other things, ARM 62X and then DMA, NXP also IMX8. So NVIDIA also Tegra chipset, you have PCI drivers also, you have GPU driver also you have, which you can basically go through from Linux kernel and understand that from there. And then of course operating system concept you need to brush up. So operating system concept you will need, even though you are focusing upon a Linux side or not, but even though you are hardware engineer, even you are bare metal engineer, even you are firmware engineer, but if you are going to switch to any company, definitely OS fundamentals will be asked, right? And when I say OS fundamental will be asked, it's not like whatever we have studied in our college days. It's like we have to focus in deep, like how the process scheduling works, what are different process scheduling mechanism available in Linux kernel, what are different scheduling classes available in Linux kernel, right? And then how the virtual memory actually works, what is the need of virtual memory, how the data translation from virtual to physical memory actually works, how the context switching works, how the context switching actually happens, and what kind of overhead context switching gives, right? And then of course mutex and spinlock, like when to use spinlock, when to use mutex. And even we have seen the person who says I know mutex, I use in project, but once you will ask him like what is the thing which makes mutex different than semaphore, so most of the people are not able to answer this clearly. Okay, somebody will say it gives the ownership. Okay, we also know the ownership, but how exactly the ownership is defined, right? So nobody is able to, so most of the people are not able to answer these kind of basic questions. So that is where we generally lack in interviews as well as in our day-to-day task, right? And then shell and system commands, like we should be very clear about sysfs, procfs, all those file system in Linux kernel, dmessage, insmode. These are the basic commands basically which we use in our day-to-day task if you are working on device development side project, right? Now we have talked about six pillars of Linux, embedded Linux, basically understanding. Now it's a high level understanding, like what exactly we should focus when we are upskilling ourselves. So definitely interrupt handling should be very clear, like how the top half works in Linux kernel, how the bottom half works in Linux kernel, how characters and block drivers works in Linux kernel, what are kernel modules, what are loadable drivers, how to load a kernel, sorry, how to load a kernel module, how to remove a kernel module, and where does module get inserted when we use insmode command, where it gets saved. So these kind of questions you should practice by yourself, right? And then concurrency of course makes an important contribution to device development project as well as in your interviews. So spin log, mutex, semaphore, we already talked about it, right? Wait queues, work queue, tasklet, and then of course communication protocol you should be very clear about, I2C, SPI, and then PCI of course, right? So why the companies basically test all this? Because they work on all these things in their day-to-day task, right? So that is why even though they will hire you as an embedded Linux engineer, so you will be working in one of all these things or maybe most of the things in your day-to-day activities, right? So most of the people come to us and they ask what are the companies which basically hire for this embedded Linux skill. So we have a lot of companies, but we have listed out few companies. We have Qualcomm, we have TI, NXP, Intel, Nvidia, Bosch, KPIT, Tata Elxsi, Sasuke, Ambitel, Continental. Automotive also now shifting to Linux kernel side basically, and also we have seen people who are working in testing side, and but they have a keen interest to switch to the development side. So I think the best way to, if you are working in testing side or validation side, and if you want to switch to development side, so you should focus upon one of the operating system. It could be either RTOS or it could be either Linux kernel. But the benefit to go with Linux kernel is that Linux kernel is generally done by experienced engineers, basically the person who is already working in industry. It could be 1 year experience, 2 year experience, or 10 years experience. The reason being is the person who is coming fresh out of the police. Most of the fresher nowadays have worked on R2s. So working on Linux kernel is basically give you an extra advantage, as well as it adds an extra skills in your resume. So which differentiate you from the freshers as well, right? Now it comes to, like, most of the people ask, like, from where they can study if they want to study from the resources available on the internet. So for Linux kernel development, you can follow a book, Robert Law. So this is quite old book. We have not received any latest revision of this book from a decade or maybe more than that. Okay, but still, if you have basic understanding of Linux kernel, you can start reading this book. And for device driver, you can basically focus upon essential Linux device drivers. For LD3, for doing some practicals, you can follow Linux device drivers. But definitely going through these books will take a lot of time, as well as the it is quite challenging to go through each books and understanding the concept by yourself, right? Yeah. So now it comes to, we are going to start our 8 week Linux kernel and device training, which is basically going to start it from tomorrow actually. So tomorrow is Monday, right? So we are starting it from tomorrow. So it is an 8 weeks training. So there will be three recorded sessions per week, live out session every weekend. And in the week 1 and 2, we are going to cover kernel fundamentals. Like, we are going to go through how to download our own kernel, how to customize our own kernel, and how to deploy your own kernel onto ARM based machine, right? In the week 3 and 4, we are going to touch character driver. We will write our own character driver. We will deploy that character driver onto the ARM based machine, right? And then advanced driver development basically will add more and more synchronization mechanism, memory management stuff in our drivers basically. And then in the final weeks of our embedded system training, we are going to go in deep into device tree, platform drivers, and then device probing, as well as a lot of kernel debugging techniques we are going to work, as well as the tools which we spoke about, ctags, cscope. Everything will be covered, as well as how to analyze the kernel logs, how to basically analyze for the kernel panics. So everything will be covered as part of this training, right? So because you joined this session, so definitely you are interested for Linux kernel and device development training. So we are going to close the coupon today. So if you want to enroll for this, you can basically use this WAP 20 coupon, which will give you the immediate discount of 20%. I'm just pinging you the link of this course in the chat. You can check it out. Yeah. So I have given the link in the chat. You can go through that. So this code will be valid and only till next 1 hour. After that, we'll be closing all the coupon codes, right? So we are starting from tomorrow onwards. So if you have interest to basically level up yourself, or if you are lacking in your current job role, you feel like you're not working on actual device development project, or you feel like your project, any project is missing from your from your CV basically. So this is the best time to go for. We are going to develop our own driver basically for a character driver in our this training. So we will be writing a device driver for a touch panel, right? So as I mentioned, you can use WAP 20 coupon code. So this will be valid only next 1 hour. After that, it will expire, right? So now it's time to take the questions. So you guys can basically ping all of your questions in the chat. I will be happy to help you out. So there is the first question. There is need any hardware for this course? So because we want everyone to do all the practicals the way we are doing it at our end. So to make it feasible for all, we are going to use an emulator for all the development which we are going to do as part of this Linux kernel and device training. So from our end, you don't need any hardware, but still, if you want to work on any hardware, you can go for Raspberry Pi, Beagle Black, depending upon your own convenience, and we'll be helping you out if you will face any issue while working on those development boards. Okay, so we will be writing touch panel driver as the final project uh, in the last weeks of this kernel and device training. So we'll write the driver from the scratch. Yes, we have a embedded Linux path basically. Let me share that as well. You can go for that. Everything is basically taught as part of this. Let me just share it. Yes, so if you want to follow the complete embedded Linux roadmap, we have this roadmap which covers C, device driver, as well as depth of Linux kernel. Okay, so do we need laptop with Linux based OS? Not necessarily. You can use a virtual machine in which you can install Ubuntu and you can use that. Okay, Sheikh Munaz, without prior knowledge on C and memory management, is this good for? Definitely, it's good for pure beginner. We are going to start from very basic. We'll first talk about what exactly Linux kernel is. So you don't need to worry about that. It's a completely beginner friendly course. Okay, Linux system programming not exactly covered, but most of the kernel programming we are going to cover as part of this course. Application code development, definitely we will be coming up with the new course in future. That is the plan. Yes, recording of each sessions will be available for lifetime. No, you don't need to know the Linux OS before. So it's this course is completely beginner friendly. We are going to start from very basic, even though you don't know anything related to Linux, but still it will be understandable for you. Yes, all the sessions which are going to be delivered, those will be available for you with the lifetime. Definitely, embedded Linux intro will be covered as part of this. Yes, so I'm pinging you the link again. You can just go for it, and this is the last time. Like we will be closing the enrollment soon for that. Definitely, if you're working on bare metal side and if you want to upskill yourself, and I can tell you one thing actually. So if you want to be on the low level or the medium side of the product companies, then bare metal is good. But if you want to upskill yourself and or you want to go for the companies like Qualcomm, Nvidia, and all these companies, so they are mostly want mostly engineer who knows Linux kernel knowledge because definitely somewhere in their project they will be using that, right? So only bare metal is not going to help you out getting the high CTC as well as targeting high profile job basically. So Mandy Linux is definitely will be needed for you. So it will be good. This question is asked by Hamnabad. So definitely this will be good. Any certificate, definitely you will get course completion certificate. Once this course is completed, you will get course completion certificate from our end. Tools in the sense the tools which we are going to use, those tools will be the open source tools. So definitely will help you out in setting it up. So you don't need to worry about it. Even though you don't know how to set up Ubuntu in your window machine, that also will help you out with all the steps. So you can follow that. So it will be there on our website itself. On our website, once you enroll for it, you will get an access of dashboard. So there you will be able to access all the sessions as well as the resources which we are going to share with you, like cheat sheets, PDF, everything will be there as part of it. So each session will be a 1 to 1.5 hours of time. Okay, and we want like anybody who is joining this course, they should practice all the practicals with us so that it will be good for them as well. And once you enroll for this course, you will get a community access. So at any time, 24/7, let's say if you're going through the course late night or early morning, you can post your queries. So somebody from our team will be answering all your queries in the community, as well as we'll be posting about the new jobs as well as referrals from our network companies in that community. So you will be getting updates related to jobs and placement as well. No, so we are going to have 24 sessions actually, right? Ahmedabad. So we are going to cover Linux kernel and device level stuff, which we just shown in the presentation. Yes, mini project building with assistant will be there. As I mentioned, we will be working on touch panel driver development. So that will be like each and every step will be shared with you. And if you will face anything, any issue, we will be helping you out there. And definitely placement support will be there. We'll be keeping you updated related to the news of openings from our network company as well as referrals. Definitely, you can add embedded Linux developer in your resume because you will be working in projects as well. So this is completely hands-on training. So we are going to do a lot of practicals in each sessions so that you will be having good hands-on of each and every concept of Linux kernel and device development. Yeah, so as I mentioned, we are starting. Yes, Dhananjay, it's good for beginner as well. We'll start from very basic. You don't need to worry about it. Even though the person who is fresh out of the college, even though the person who is working in testing side or the validation side, if they want to have development project experience in their project or the CV basically, so this training will definitely help. You can target device development based roles, Rakshit. Embedded Linux role, Linux kernel related roles, even the automotive companies who want Linux kernel knowledge, you can apply for that as well. Yes, mini projects will be part of it, Dhananjay. So that also will be beginner friendly. You will be able to understand. It depends, Fazal. Definitely, if you have that much bandwidth, if you can spend time within Iskander and as well as Artos, you can have understanding of both. That's not an issue. So, Vignesh, you can ping us on this number for complete embedded C Linux device course. Let me ping you the number. Someone from my team will be sharing you the coupon code for this course. Definitely, embedded Linux is good future in the next 15 years because AI is taking place. So most of the application part is anyways going to be taken over by the AI, but kernel will still will be there. Definitely, Lokender Nath, if you have bare metal knowledge, so having Linux kernel knowledge is definitely going to add a lot of further, more opportunities in your career in embedded domain. See, knowing only bare metal will not help in the long run because even the people who is coming fresh out from college, so they also working on the bare metal side. So, being an experienced engineer going forward in your career, you should have focus upon other stuff as well, right? Americans as well. Yes, so we are going to use emulator, QEMU emulator that we are going to use as part of this Linux kernel. Okay, so we will be doing all the practicals on that. Art was also good, but see, the thing is, I will tell you, the people who is coming from the college, so he already has the background, like he has to focus on artos. But most of the time, the engineering graduates or the person who is having 1 2 years experience, they feel like Linux kernel is the advanced things. But definitely, we have seen the scenario. Companies are asking for the person who is having Linux kernel experience, but we have not received a single resume who is having actual experience for Linux kernel development. But the person's lot of resumes are there with Artos experience as well as bare metal experience. So Linux kernel is definitely advantage over the Artos, I would say. And Linux kernel is quite complex as well. Three sessions we are going to have per week: Monday, Wednesday, and Friday. What will be better for automotive? 4 years experience person working on AutoSAR. Okay, so let me tell you that our boot camps as well as Linux kernel device development, 40 to 50% people join from the automotive domain actually, because everyone nowadays in automotive feels like they don't see much career growth on the automotive side, as well as they don't see that salary hikes as well in automotive. So being an automotive engineer, you should choose one path. First of all, you should brush up your C fundamentals, because we have seen person who is working on the automotive side, they lack somewhere in the C programming. So you can focus on that. So if you want, we have the boot camp designed for the people who wants to start from C and then move on to the RTOS and the Linux kernel. So in the structure way, we help engineers to focus on that. And then if you want to switch to Qualcomm like companies, then you can choose between RTOS and Linux kernel. But Linux kernel is advantage for you, because even if you will search on LinkedIn like Linux kernel jobs Qualcomm, you will get n number of job. Qualcomm is hiring in mass nowadays for Linux kernel profiles actually. So you can go for it actually, I will say Fazal. So that is the my suggestions from my side. Okay, Shreya. So as I said, like we can, we will help you out in setting up the emulator at your end, so you can do all the practicals which we are doing as part of this session. You can follow our session and do the same practical at your end as well. Vignesh is asking what all prerequisite for this course. Nothing. If you have basic understanding of C, that is fine actually, because we are going to start from very basics. See, the thing is, it really, Steve is asking how much time it takes basically to do the mastery on device Java skills. So it really depends upon how much time you're going to devote that. 2 3 months is fine if you are working day in and day out for device development part. Actually, 3 months are quite enough for you actually. Yes. So just to reiterate, in the next half an hour, we will be closing this discount code, and as we are finalizing the batch now, so we will be creating a schedule accordingly. Okay, so Twinkle is asking what about 3.5 year experience in embedded system and also 4 years of a career gap for that. This will be helpful for not. See, the thing is, with respect to gap, even though if you're coming from RTOS, Linux kernel, or from bare metal or firmware, so I understand there are challenges in India at least with the gap, but it can be covered depending upon your the companies which you are referring. So Qualcomm and Nvidia, all these companies basically launch few programs for the people who have the gaps. So you can be part of those. Okay. And now it comes to like 3.5 experience. If you will go for Linux kernel device development, definitely it will help you out. So somewhere you can show in your resume, like even though there was a gap in my career, but I have worked for Linux kernel device development side, and these are the project which I have worked upon. So definitely this will help you out. See, the companies find a problem during that gap. If you are not doing anything, then it's a problem. But if they feel like during that gap as well, you were connected to the technology as well as the tech stack which you were working, so sometimes it's beneficial for you actually. Resume support is basically not part of this training, but placement support is there. Resume support generally we cover as part of our embedded system into prep bootcamp. So there we also take mock interview as well as uh, all the interview related stuff we cover there. All right, we have 5 10 more minutes. If you have any questions, please ask. Linux commands anyway. See, the thing is, Linux command are needed for a person who is working on application side. Being an embedded Linux engineer, you are going to use Linux in your day-to-day activity. You don't need to particularly focus upon Linux commands. You will learn these commands anyway with this training itself. So definitely you will learn. Okay, any other question? Okay, without hardware, how we can understand? So as I mentioned, we are going to use emulator. So that is also equal to hardware only. So a lot of things, 90% of the things you can find in the emulator. So once you will practice your driver development on emulator, you will have good understanding of that. And how many hours of training will be there? So as I mentioned, each session going to be 1 or 1.5 hours. So total we are going to have 24 sessions as part of it. Interview questions, yes, it will be covered. Like we can share you few PDFs because we already have all the materials as part of our interview prep boot camp. Definitely, we can help you out in that. Notebooks related course, we'll have our own PDF that will be shared with you as part of this training to help you out in understanding the concept. Okay, sure. I think then we are closing the session now. So if you want to enroll for this course, so I will suggest you to enroll in next 10-15 minutes and then we'll close it. Okay. Thank you so much guys for attending this session. Sure. Thank you so much for giving time to attend this session on weekend. We are dropping now. Definitely, Salesh, it will help you out. Even though you have 5 years experience, you can show this experience as a development experience. If you still have any doubt, you can ping us on our number. I'm just giving you here. Oh, thank you. Great, Dhananjay. Let's see you tomorrow in the training.